Hi, I'm Eric Jeffers from the Big Nerd Ranch, and I'm going to be talking about process lifecycle management and state management today. And this is pretty important stuff because you want to make sure your app always restores to the right state, shows the user the proper information, etc. So I'm going to give you a walkthrough of, first, what the application states are. These are going to be things like running, not running, terminated. And then I'm going to walk you through this process lifecycle and show you basically how the app changes states and what's really going on. I'm going to show you a little bit of application activation and then go into detail on the resuming, suspended, and terminated events. And then the most important thing, really, is saving the user state when these events happen. And I'm going to show you how to do that. So to start, let's just kind of go over these application lifetime states. All right, so this diagram, I could spend all day on this diagram. Let's kind of walk through it. So at the start, the user first installs your application, or the operating system restarts, or something to basically completely wipe the state of your application. And what that is that's the not running state. And basically, this can be triggered by the user clicking end task, or killing your process from Task Manager, or when you first install, or when they hit Alt F4, or when the user closes the app from dragging it down from the top, and about 10 seconds after that, it goes into the not running state again. And so from the not running state, if you open the application, you get this activated event. And that brings you into this running state. Once in the running state, you can activate again. This would be things like file activation. Say if your application was already running, the user double-clicks a file, opens it up, you loop back through an activated event again and stay in the running state. Then, after the user's been using your app for a little bit, it suspends if they close it or navigate it away, and you end up in the suspended state. From here, there's two different things that can happen. You can be terminated, and end up in the terminated state, which is like not running, but it's semantically different. You're going to want to do some different things when you're coming back from this state. We'll see really how to handle that soon. And then from terminated, you can activate again, go back to running, or from suspended, again, you can take the resume path and come back to running. I'll go into detail along a lot more of these states soon to show you what's actually happening and what you really need to do in order to restore proper state. So some other states are closed by user. If you end up in the not running state, and then there's a 10-second delay, you can end up in closed by user. And then you want to do some special things when restoring from that state. And really, this is that diagram. It's not quite as clear or really as nice and clean as a lot of other mobile platforms, their process lifecycle, but we'll see how to handle it all. So, execution state. It's this property that you get, that you have access to when your application launches. Basically, on onLaunched or in other activated events, you can ask the arguments for the previous execution state. And so in the case of terminated, we want to do some asynchronous restore of something that we do. And really, what we have is when we're terminated, we want to restore the user's data. When we're closed by user, we want to start new, go to the fresh screen of the application. And when we're not running, we also want to do the same thing again. This would be the first launch. Any questions on anything like that? Okay. So that's the states. And now we're going to see more about how these states actually work and what you should do with them. So as I was talking about yesterday in contracts and activations, we have this big list of possible different types of activations. And so we can launch from file activation, protocol. Somebody could activate us with a contact picker, or if they're requesting to open a file from our application. Lots of these different things. And so that brings us into this running state. And we have to make sure in all of these different activation types that we're checking the previous application state and making sure we're doing the right thing. In the case of search, as you saw, you can activate an app with search, and that can bring you into a search result state where you would want that to happen. Or if they don't enter any query text, you just want to go back to the normal state as if they had opened your app from the tile. Right. And so here's just the actual method names and what they do of a lot of the activation points. OnLaunched, again, there's there at the top. That is just one of very, very many. And the rest are here. And these, again, they're defined in app.xaml.cs, main entry point into your application. And you want to make sure you're just checking these state things properly. So now what I wanted to do was just kind of show you a demo of how you can basically test out your state and make sure you're doing it right in Visual Studio. So if we go in and make a new Visual Studio, we'll create a new blank project. And so you can see Visual Studio has already made this code for us and on launched. And what it has here is arg's previous execution state. If it's terminated, then we want to load state from previously suspended application. And so when you first launch an application, this is going to come up on my monitor, but we'll see that the previous execution state was not running, right? That's because our app has just been installed. In this case, it was side-loaded by Visual Studio, not through the App Store or anything. And we're in the not running state. So this if statement's not going to go through, and we would not actually restore any application state. So we continue running. Now our app is now in the running state. And so what we can do is go back into Visual Studio and force it to suspend. We'll see more about that event in a moment. But right now, I wanted to show you suspend and shut down. So that happened. And now our app, Visual Studio is no longer debugging, but our app was shut down. It was terminated. We'll see that again here. When we run it again, our previous execution state is now terminated instead of not running. So this means that the user was open in our application and then they navigated away to it to, say, a different application, but they were somewhere deep within a navigation hierarchy or had something open on the screen or something in a text box, and you want to restore that. From not running, you don't want to restore that. But from terminated, you want to restore that. And so this is kind of like, an iOS. We would save our user state and application will terminate. We want to do that in suspending here, and we'll see that very, very soon. Let me close this guy. All right. Back to PowerPoint. This is not working. Okay. So, resuming and suspended. Very important events. So the user launches your app, and as we've already seen, you are in the running state. This is where your code gets to run. Then you can get a suspending event. This is when the user navigates away to a different application. Switch to a different one. And when you're suspended, your application, it's not closed really. You just get no CPU time. What happens is this image in memory just stays there, and nothing's running on it, but it can come back instantly. So when you're resuming in that event, you don't actually want to load up anything because your text boxes will still be populated with whatever data you had. All you'd really want to do in this event is basically say, like if you had any open network connections or things like that, reinitialize those. And then when you're in suspended, you can still get a low memory. And it's not a low memory warning, it's not a separate event, but it is terminated. Your app will just die. You won't be notified of it. So on suspending, you want to make sure you're saving all of your state in case you get terminated. But if you come back from resuming, you don't need to use that information that you saved. You only need to use it if you're coming back from terminated. So here's just kind of a little animation. It's going to hopefully make that a bit more clear. We have this first application. It is in the running state. Then we switch to application 2, and app 1 is suspended. After a little bit of time, it's not immediately suspended as soon as you switch away. It's just suspended just a little bit after, about 5-10 seconds. It's not really deterministic. So then we switch to yet another app. This app 2 then goes to the suspended state as well. And these applications, they're still fresh in memory. They haven't been terminated yet. They're still in RAM, loaded. Then we open another app. App 3 goes back into suspended state. And then memory's starting to run low. So the operating system decides it's going to completely kill our application, our first one that we launched. And again, this happens without notification. So there's no event that you get on terminated. It's suspended is all you get. Switch back to application 2. It comes out resumes instantly. It doesn't have to do anything. No synchronous loading of data. Everything's still fresh. And it's the end of that animation. So I said earlier that there was about a little bit of a delay from when you switch away from your application and end up in the suspended state. And so you're not really aware of that through normal process lifecycle notifications. But if you want to do something when that happens, there's this visibility changed property on the window that you can subscribe to and do something when the user immediately navigates away from your app, in case you don't want to wait for the suspending event. And so, yeah, like I said, it's about 10 seconds. And it's not common practice to do something here, but in case you wanted to. Some apps, they need to maybe dispose of a lot of big, high-quality images they had going on, something like that. So I've been talking a lot about the suspended state thing. And here's just some things you need to know about the suspended state. Like I've said, they all remain in memory, no CPU or network or anything like that. Every thread that's going on is, again, just instantly paused. But if you have background tasks going, those will still run, as we talked about earlier. And so the Windows operating system, it's going to make sure that your application is not suspended in any bad spot, in anything where it would cause another application to deadlock or anything like that, because that would be bad. And you really have no idea when your app's going to suspend, so it's up to the OS to make sure that that goes all according to plan. So how do we deal with the suspended state? It's the suspending event. Like I've said many times now, and it's really important, there's no termination event. So when you get this suspending notification, this is the only chance you have to save user data. And there's a couple of different ways you can do this that we'll see very soon. And really, this is where you want to release any resources. Like if you had a lock on audio and you were playing audio, you'd want to get rid of that here. And you'd also want to dispose of anything big that you had, right? And then save your application state, naturally. And so again, when you come back from resuming, with on resuming, you're not going to be loading this data that you saved because it's all still going to be fresh. On suspending, you're planning on being terminated, but there's a chance that you won't be terminated. What's up?
So you mentioned about audio. If you have audio playing in the background app, would that be suspended or would that still be?
The background task, or the question was if you had audio playing in a background task, would that be suspended as well? The background tasks are completely separate from this. If you had audio playing just from your application and you didn't want it to keep playing when the user navigates away, say it was like a video or something, doesn't really make a lot of sense to keep the audio playing when they're not watching the video. You'd want to release your lock on the audio that you have. So background tasks, though, completely separate thing. They have nothing to do with the suspending events and everything like that. Does that answer the question? Cool. And so you can see, it's just on the app XAML CS, we have this method on suspending. And what we do is, we get this thing called a deferral. And we've seen a little bit of those before. And what this lets us do is, this on suspending event's going to run, and if we don't get this deferral, then it's just going to run and not care about our asynchronous stuff. Like, for example, if we didn't get this deferral and we called this suspension manager save asynchronously, there's the chance that our application could actually be suspended and our code wouldn't get to run. It would stop our async method that we have saving our user state. So what we have to do is grab this deferral object that says, hey, wait till I'm done, and still let me run code until then. And then you call deferral.complete when you're done. And you have about 5 seconds to save state in on suspending. It's kind of a long time. You can do a lot in 5 seconds. So the resuming event. Resuming, again, only called when the app is resuming from the suspended state. Resuming is not called if the application was not in the suspended state, like not running, terminated, closed by user. And so, like I've said earlier, this is exactly the same kind of thing as suspending. You subscribe to the event in the app. And then with the implementation, you just want to make sure that you're refreshing network connections, maybe check for mail updates, that kind of stuff. So now I'll just show you suspending and resuming in Visual Studio. It's pretty simple stuff. Let's go back to our application we had, and right here, Visual Studio's automatically implemented on suspending for us. How nice of it. So we can set a breakpoint there, but resuming is not yet implemented. So let's go ahead and do that. Actually, yeah. Man. All right. And it's going to whine because we haven't actually done that yet. And let's just set a breakpoint here, not actually implement anything. No overload. Okay, that's better. Object E, I got the arguments wrong. But fortunately, Visual Studio has my back. Okay, so we run our application. And you can't see it, but it's on my other monitor. Black screen, right? Okay, so now we hit suspend. And here we are in our suspending event, just like you'd expect. We have this event args thing. Shows us a lot of different information. Like a deadline. Okay. And then we can continue running. We're now in the suspended state. Everything's still fresh in memory. Then we can resume. And here we get our on resuming. Works exactly like you would expect it to. All right. All right. So what you want to do in these events is saving user state. And Visual Studio and the Windows 8 platform, they give you a lot of things for free by default that help you save user state. This is kind of like a flow of what you want to make sure you're doing and where you want to save data depending on the different states that your application can run in. So in running in suspended, your app's still in memory again, so you don't really need to serialize, save stuff when you're in these two states. But when you're going to be ending up in not running, you want to make sure that you're storing like local and temp app data. There's storage folders that are provided for you where you can store these things. There's also this concept of roaming settings that we'll see. And then, through a system restart, you're going to want to use the access cache. This is yet another storage API that's provided to you by Windows. And then, roaming app data, that's synced to cloud. So if you have the same application installed across multiple different devices, you can share basic, kind of like just a small little dictionary of settings and state there. Not that you'd ever want to send your state over to a different device. That's not right. But this is where you can just save things. So, and additionally, there's password vault. So if you have user accounts and that kind of information, you can save that kind of stuff there. It's very secure. Make sure user credentials are stored safely and securely. And then it also syncs those to clouds across different devices so the user doesn't have to enter in the password multiple times. Right. And so here's this roaming settings thing. And so sometimes the user will specify different settings in their code, or when using your app, and you want to make sure these transfer across different devices. And that's what this roaming settings is. There's also local settings, which everywhere where I've written roaming settings here, you could replace with the word local settings, and it would work the exact same way. And so what we're doing here is we're grabbing our roaming settings container. Again, this could be the local settings container where we could then store a user state. But roaming settings, it's nice to know about. And so it's just a big dictionary. So we can say roaming settings, message, we want it to be hello world, right? And then we can get that out of there. We can also do some other cool things, like creating containers where we can nest other dictionaries and things into. And so roaming settings, I think right now, there is a way to query how much space you have left in it because it's synced to the cloud, and it's called, you would ask for this roaming settings, and I believe it is application data roaming storage quota. And right now, that's about 100K. So you can't store a whole lot in here. Like, you're not going to want to put images or videos or anything like that in here. But you can store strings, basic stuff like that. Maybe even like some JSON objects, that kind of stuff. Basically, big key value store in the sky. Right. So additionally, Visual Studio, when you create a new project, gives you this suspension manager thing. And what this is it stores, it's kind of hard to explain. It stores both navigation state and gives you access to a dictionary where you can customize certain things. So here in onSuspending, we're just getting to call this hello world common suspension manager save async method. And we'll look at what that actually is doing in a moment. But first, before we can do that, we have to register our frame with the suspension manager. And the frames are what hold the navigation context. So the frames can know, what page you've navigated to, where you are in your application. And when you call the save async method, it's actually storing the navigation context that you're in so that when you restore from it, you can automatically navigate to the page or frame that the user was in. Again, the same deferral patterns happening here because it's asynchronous. So here's that session state object, kind of what's going on. This is from the layout aware page template that's given to you in Visual Studio. It's included when you create a new application, like grid application or something like that. And basically, in this onNavigated from method, that's a part of every page, we take this frame state, we get it, there's a convenience method on our suspension manager, and we can say, here's our frame, give me a state from it. And from there, we can store it. Right? Okay. And our dictionary is also our page state, and this is where you can put user things like what they've entered into a text box or something like that. If you're terminated. Yes? I'll repeat the question. Go ahead. If you've navigated into your app several layers deep. Yeah, to save your navigation context. This is onNavigated from is called when the user leaves a certain page. And so what this allows you to do is basically save the path that they've taken to get to a certain page, such that when you restore your application, your back buttons will still make semantic sense. So when they hit back, they go back to the page they were in before and everything like that, before your application was terminated.
So when an app is restored, is the app responsible for calling and restore for each of these frames, or is it automatically stabilized?
Using the templates, using the suspension manager template, the app will automatically be restored to the place you want to be, but you're still responsible for making sure that that page that they get to has the right content on it. Okay? Does the session state save locally? Yes. On local storage, I'm not positive, but it's a whole lot more than roaming storage. What's that?
No limit.
No limit. Okay.
So this page is the concept of page naming is assuming that you are using the navigation template API. If you are not using it, this won't work.
Okay, the question was, assuming you are using the navigation template that's given to you with Visual Studio, all of this works, but if you're not using it, it won't work. The answer is basically yes, but you would have to re-implement the same functionality yourself. Really, there's no reason to not use the template, unless you're doing some pretty crazy things. The template's there, it's very nice. It really should almost be part of the API itself, but it's not. It's a Visual Studio template. Yes?
For Zephyr-based UI and JavaScript-based UI, is this template what are you same for the Java-based UI?
Oh, you mean for the JavaScript applications? For JavaScript applications, I think saving user state's actually easier because you can serialize things to JSON objects, and I don't think these templates are given to you in that way. Jaime, perhaps?
We have similar functionality, and I think it's the same to, you can repeat this.
Right.
We have similar functionality where we do give you a navigation framework, even with JavaScript. And then they're both about the same with regards to, they're both very easy to save. You just put stuff in a dictionary and saving it, or you put it on a JSON object and save it.
Right. So, yes, in JavaScript, it's very much the same. Things are in dictionaries, and you can save them to the local file system. Yeah. Any other questions on this? All right. Well, that's pretty much it on PLM and state. Here's just some best practices that I've kind of said a bunch of times, but it's nice to get them in a table. So when your user's using your app, save your data incrementally as they navigate from different pages. That onNavigated from method, you should save the state for each page as you leave it. When your app's being switched from back into the suspended state, you want to save where the user is, and the suspension manager is what takes care of most of this for you. So when the application's not running and it's activated by the user, you want to bring back and restore the state that they had, as if they've never left. You don't want them to know that your application was actually terminated. And then again, if the suspended app's launched, you don't actually have to do anything except refresh your network connections, that kind of thing. That's it. Any questions? Yes?
Could you go over this saving data incrementally? You're saying, you said that it rebuilds the navigation tab automatically, but that's only if I save it every page?
Well, this template, this is part of the layout-aware page. The question was, if do you have to save the state in every page yourself in order to get this for free? Is that what you're asking, really? Okay. So in layout-aware page, which you should subclass for all of your pages, it's this class that's included as a template in Visual Studio. This method's basically written there for you. You're responsible for loading that dictionary with data from the user, whatever they're doing. But this method exists in layout-aware page. It'll actually call through. It's not written here. I took it out for brevity. But it'll call through into the subclass of layout-aware page on navigated from, and will let you save user state.
So what I'm saving on every page is data that I might want to refresh.
Right. So yes, what you are saving on that page is data you might want to refresh every page, but the navigation path you already have. That's done, that's abstracted away from you as part of these templates. Is that okay? Anything else? Still got a little bit of time. Anything from the Twitterverse? Nope.
I don't see the screen, but there's a question on Twitter that said, which I didn't understand, but it said, how does this map to iOS?
So there's a question on Twitter apparently that says, how does this map to iOS? And really the answer is, it doesn't really that well. In iOS, you have things like application will terminate. So I guess kind of like on suspending would be your application will terminate. But it's not actually the application dying right then, like it is an application will terminate. It could just come back instantly, but that's still where you'd want to do everything that you would be doing an application will terminate. And then there's no one single entry point into a Windows 8 application like there is in iOS. You can activate it from tons of different places, like from contracts, search, sharing, whatever. And you have to make sure that your state's restored well there. So it's really quite different. It's no longer launching an application. The roles of the application has been kind of blurred, so you can really get into it from different ways. Is that kind of... Okay. Again, the Twitter person can't tell me if that was a good answer, but... Oh, we have a microphone now.
Actually, on iOS 6, you had 5 from 5 on. You do have suspend, resume, and application saving state stuff as well. But it's not to this extent, and
right.
You don't have the multiple entry points. But one of the problems actually with the iOS model is if you're using device stuff, and you're brought back, putting like your device sensors and setup and things like that are sort of global. putting them back in place. Do you have the same? Are you going to have the same issues here, or
Yes, and when your application's suspended,
Right.
You're going to want to like release locks or anything you have on like audio or accelerometer if you have
Okay.
exclusive access to that. And then on resuming, you'd want to refresh those.
Okay.
And when your application's terminated, the control to that kind of stuff's automatically taken from you. But still, you'd want to give it up in suspending.
So I think Eric's answer is right. When we suspend, on the Windows world, actually suspend is interesting. When we suspend, we literally just stop pumping messages to your app. So Eric's right. When you suspend, you do want to release things that are, expensive, I would call it. Like if you have media playing, you'd want to release all that because that's just going to continue to consume memory. But you don't have to do things. So for example, if you're suspending and you decide, I'm just not going to release the accelerometer, that still works. When you come back, we would still work and everything else. So you don't absolutely have to, but it's definitely the recommendation. The way we do it, if you look at suspend and how things work, is we will keep as many applications running as there's memory, right? And our certification requirements do say, hey, decrease your memory, very much like you do in iOS, right? Where I think they're a little bit more stringent on, hey, you have to because the devices have less memory. So in our world, the best practice is to decrease it, but you don't have to release the resources if you don't want to. So there just won't be now. They won't be pumping any information if, for example, you have something like Endomondo or any of those applications that need constant GPS. And your application suspended, you're going to miss all those events, right? We're not going to queue them. We're just going to flat out drop them.
Yeah, and you don't get them when you come back.
Yep. But
They're
if you
just-
don't release your code, you'll still start coming back or working when you come back.
But do you have to restore, not location services, do you have to re-enable location services?
The question was, do you have to re-enable location services when you come back from the suspended state?
And that's the point. I would tell you from a good practice standpoint, when unsuspended, go ahead and shut down location services and stop and restore it on resumed. But if you don't, then you don't write the code to suspend or you don't write the code unsuspend, and when you come back, location services will pick up where you left off. So we literally keep your process in memory. We just have a way to block it.
So you say there's multiple entry point for each app. So does that mean every entry point can do the suspend and resume?
Yes. So when your app's activated, there's this activate thing that's called, and there's just different ways that can happen. These are the different things that can activate your application, but once it's been activated, you're in the running state. So from there, you can go into the suspended state. So if somebody activated my app through file activation, I could still go into the suspended state once they decided they no longer wanted to be in my application. Does that answer your question? Microphone. Yeah.
So there could be multiple suspended state for each app, right?
No.
Means that every entry point has or they share the same.
But they all go to the same suspended state. There's no different suspended states. There's only one suspended state. There's different ways that your app can get into the running state. So if we go back to this diagram, from not running, that's just the state your application's in. It can be activated through any of those possible activations, like file activation, cached file updater activation, launched from tapping the start tile. And then once that happens, you're in the running state. It doesn't matter how you got activated, you're now in the running state. From the running state, you can only be suspended. And that's just the same one suspended state. There's not like a special file activated suspended state. Does that make sense?
But when I resume from the previous suspend state, it could be from different entry points. So I didn't need to, in the code, I need to differentiate. Now it's in different entry points. So when you resume from the previous suspend state, it could be different display.
So basically, what would happen with that is if somebody had opened a file on your application and they were in like this editor that was editing the file, your code should just work like that normally. And if that app's then suspended, you don't need to know how it was activated. You just need to know what state you were in before it was suspended. So then when you resume from it, you just check and see what state you were in and then restore that state. So if it was a file activation, they'll be in the file editor. If it was a contact picker activation, they'll be in the contact picker, that kind of thing. Okay. Yes.
What happens if you don't implement all of the various activation methods?
Oh, you don't have to implement all of these.
But if, for example, if you don't implement on, well, I guess on activated probably, or on launch activated probably required.
On launched, you have to
Right.
implement. On activated this is where like everything here will only be called if you've declared the capability.
So these
for it.
are these all delegates or are these?
These are all contracts.
Contracts,
And
okay.
extensions. So like on search activated, if I don't put in my manifest that I'm a search capable application, then on search activated will never be called.
But if you put in your manifest and you don't implement it, will it throw an exception or will it not build? Or?
Horrible things will happen.
Okay.
It probably won't build, but just don't do that. There's no reason to do that.
Don't do that. That's always the best answer.
Right.
You'll just end up with a black screen. That's what, because something's going to call and nobody's going to load your UI. So that's just what's going to happen. You won't crash or anything, but you'll just have a black screen.
So don't do that.
Definitely don't do it, though.
If you have background threads running, does that
Background tasks are
Right.
completely separate from this application state. Background tasks, as we kind of talked about yesterday in contracts and extensions, they do their own thing. They have their own limits of being able to run, refresh time, that kind of thing. So if you have a background task playing audio, if your app's a music player and the user navigates away from your application, that background task is still going to be running. It's not going to worry about the suspended state or the terminated state. Yeah, this guy.
So if my app has a file open, let's say, and then the user puts it in suspended state. So I've saved, various things into those remote caches and things like that. Now, I assume then if they come in on the on-file activated, it means perhaps they chose a new file to open with my app.
Right.
So I have to throw out all that old stuff that I saved because presumably I'm starting something new. Is that a correct?
Yes, that's right.
And then I'm responsible for getting rid of all the remote state stuff as well that may have been pushed out to the cloud, right?
Yeah.
So I zap it all out and start
Yep.
fresh. Okay, thanks.
And then I got a question up there from the Twitters. How much time do you have to complete some computation when the system informs you that you're suspending? 5 seconds is the answer. CPU seconds. Or
Seconds.
clock seconds? Okay, clock seconds. Hold on. We're going to do the microphone on this guy first.
Does the background tasks have the same life cycle as
No.
regular? So are you going to talk about
Background tasks, they don't really get suspended or resumed from or anything like that. They're a completely different animal. Yep. Thank you.
I should know better by now. I mean, I haven't got my own microphone yet. So you mentioned that background tasks are separate from this stuff. So is there a good architectural practice of having a background task going that's can't speak this morning, squirreling away state or things like that?
No, that's not good practice at all.
Okay.
Background tasks should have nothing to do with the state of your application.
Okay.
They're only used for refreshing, pulling the network stuff, or playing audio, or control triggers like VoIP and stuff like that.
Okay. Good. Thank you.
They're actually, it's almost even like a separate piece of your application. If you just kind of cut it in half and said, this is the stuff that's going to run in the background, and then this is my normal thing that the user sees.
Hi, good morning. I have a quick question. iOS makes the distinction of events when it will enter a certain state as opposed to when it did enter the state. So does Windows 8 also provide those distinctions in events, or do we get, for example, the on launched when the application is fully launched? And the reason they make that distinction is so you can prepare the application
Right.
while the transition is happening, as opposed to when the state is actually completed.
There's no will be launched or anything like that, or will be suspended, but the on-suspended events, that's where you do everything that you would normally do in will be terminated. Because it's kind of it's kind of a little bit semantically different. On suspending, I'm suspending right now, is almost kind of will be suspended or will be terminated or something like that. So that you do semantically, you'll do the same thing that you're doing in those will be whatever events, but you'll do them in these on events. Any more questions? Lots of questions.
How do you communicate between background task and the app if they are?
I'm sorry, one more time?
How do you communicate between background task and the app?
That's there's a lot that could be said about that topic. Jaime, do you want to give it a clear answer?
How do you communicate between a background task and the foreground app if you happen to be running at the same time? So, first of all, you design such that your foreground app it assumes that you're never running or you never depend on your background task, and you design for your background task. You design something that says, look, my background task is going to run every 2 hours. But my UI might or might not be running at all. In fact, I always assume your UI is not running at all, right? So if you want to communicate back and forth, what you do is your background task will come up. It'll do what it needs to do. Let's say it was something that downloaded, the news for the day. You just literally download the news and save them to a file or save them to local state in your application. So the background task and your foreground application are going to be using the exact same, folder, the exact same temp data, everything else. So you save all your data there, and then when your application launches, it can check, hey, do I have new data? And then you do it, right? So just assume that they're separate, and then use state to communicate back and forth between them. So. Music is slightly different because on music, what you do is music is a background audio, so I don't consider a background task. On that one, what we do there is when music happens, what you do is you set up your media player, and you're going to be playing audio, and then on the suspending event, you can wire up to some events for media control. And then that will actually plug you onto the system UI for volume and play and certain, the functionality that you need to continue playing music, right? So that one, music is just background audio, is not a background task. Music continues to run. So the way if you think about it, you write your application, you're playing music, and then out of the sudden you get suspended, so you will get the suspended event, right? But your music will continue, and then there's callbacks that will be going back to your background audio. Right, so you subscribe to a couple events for background audio, and then you'll get callbacks that say, hey, please get me the next song, and do the right thing. So that's different from background tasks. The answer that I gave you earlier was just background tasks, which are triggered by the OS, which are launched, done by the OS, most of the time. So background audio is it's different. That's the difference in category where we don't put them as a background task. Yep.
The question is, how would you do something like peer-to-peer chat or IRC chat? And that would be a control channel background task, where you have your quotas are lifted and you have access to other things. Yep. And I think we are well out of time.